We're living in a time when large language models are virtually transforming the way how we typically do things. And there's a lot of sectors that are going to get heavily influenced by the uprising of these AI technologies. And data science sector is definitely one of those that's right up there at the top. And it's inevitable that as the days pass by, we will somehow begin to incorporate these AI models as smart tools to our day-to-day workflows in multiple ways. And as I said, one such sector where the advent of these AI models are going to rattle up how we do things traditionally is the field of data science and data analytics. So in this video, I'm going to put to the test two large language AI models, including the one that's currently making headlines as it just got released a few weeks ago, which is Grok 3, Elon Musk's XAI's latest AI model, and its competitor is going to be Anthropic's Claude AI model, and to be specific, their Claude 3.7 Sonnet model, which they claim to be their most intelligent AI model yet. Now, keep in mind that I'm not going to expect any silver bullet answers from any of these models by any means, and honestly, I think we should not, because these AI models are best used as smart assistants more than anything, which means we are not going to disconnect the involvement of the human in any form when it comes to getting these tasks done. And I have selected 4 common types of challenges we come across in the data science space when we typically work on data science projects, and I'm going to judge the ability of these large language models to not only help me get to the solution in the end, well, that's the goal, but I'm also going to assess how it applies logical reasoning for why they decide to think or respond in a certain way to my questions. Alright, without further ado, let's get to it. So the first task that I have selected is what's called a data cleaning and manipulation type of a test. And as you may know, when we get our hands on a data set, before we jump into doing any analytics on it or use it for building any machine learning models, or basically before we do anything useful with it, we need to go through a data cleaning or a data checking step. And I have downloaded a time series dataset like this, which describes a few weather-related variables of a specific region. And we have daily records of things like rainfall, minimum and maximum temperature, wind speed, and a column that describes the nature of the weather, as in if it was raining, sunny, or whether it was snowing on that day, and so on. Now, this looks like a totally decent data set, but we would actually have no idea about all sorts of data anomalies and things that wouldn't make sense unless we take a deep dive at it and really start picking through things, and that's where these AI models can come in handy. So the task is, I want these AI models to get this dataset in and put it through a data cleaning and pre-processing step before it can be used for performing any further data analytics. Basically, flag if there happens to be any erroneous or abnormal records and make sure it's fit to be used for any subsequent data analysis steps. So as you can see over here, I have saved this dataset into a CSV file like this. We have Claude 3.7 Sonnet model on the left-hand side, and we have XAI's Grok 3 model on the right-hand side. So what I'm going to do is I'm actually going to paste the prompt like this, put this dataset through a data pre-processing and cleaning process to ensure it's fit for any downstream data analytics or machine learning tasks. And I'm going to attach the CSV file using this button right over here. So let's go ahead and select the CSV file and click on open. And I'm basically going to do the same right over here as well. And I'm also going to make sure that I tap on this think button and go ahead and attach the CSV file just like this. All right, now let's hit enter and see what sort of a response we're going to get from both of these models. All right, now let's have a look at the process both of these models went through in order to analyze this dataset and what sort of key pieces of information it tried to extract, just based on the nature of the dataset. So right over here, you can see it actually created a weather dataset pre-processing pipeline, created a function called preprocess weather data, and within that function, you can see a few crucial steps. For example, well, obviously loading the dataset and doing basic data explorations to find things like whether there are any missing values or not. And also it's going through the process of identifying things like outliers in temperature, wind, stuff like that. And finally, it's doing a data validation process. And it also actually creates a new function to generate a data quality report, which is quite nice. And finally, using this function, we can save the pre-processed data to a CSV file. So if I go ahead and exit out from this, So it actually managed to identify 4 different types of issues based on the analysis it performed: data format issues, extreme outliers, so major outliers in precipitation dataset as values as high as, well, 15,000, and outliers in temperature and invalid wind values. And it manages to catch things like the data inconsistencies, in some cases where minimum temperature was higher than maximum temperature. Well, obviously this is something that shouldn't be happening. And having negative precipitation values, physically it's impossible. And if I concurrently try to look through the CSV dataset to make sure that what they have identified over here is legit, well, I can definitely spot some things right away. For example, for temperature, the maximum temperature having 500 degrees, which definitely is an outlier. And when it comes to precipitation, yes, having negative values like this, it actually has managed to spot that. And even things like the date format issues. So for example, you can see that for the most part, the dataset follows a certain standard format, day, month, and year, but you definitely can see rows where this is not the case, possibly due to some sort of a recording or typing error. So it's pretty nice that it actually managed to spot all of that, and it managed to provide me with a very nice report like this. So now let's jump over to Grok 3 and see how it managed to understand my dataset and what sort of insights it actually managed to obtain. So you can see that the thought process went for about 55 seconds. If I expand this to obtain the details, during this thought process, you can actually see it spotting crucial things like, well, having unrealistic temperature values and having to handle non-numeric values. In certain cases, for example, it says that there should be one entry called 5 instead of a number for the column wind, which I actually managed to spot. It's right over here. Well, during the data entry process, maybe somebody has accidentally typed out the actual value in string format rather than actually inputting the correct value. And similarly, it's also spotting errors like extremely high precipitation values, which it thinks is possibly a typo. So you can see that it's actually going through the standard procedure, just like the Claude AI model. And I'm just going to directly jump into the main findings. So here, it actually spotted that the dataset is having erroneous date entries like this, and it's correcting that. And again, ensuring that these 4 columns should be having only numerical figures. So things like 5 entered as a text for wind is something that's not acceptable. You have to correct that. And also things like outliers, 1500 degrees for maximum temperature. Well, this should definitely be a typo or some erroneous value. So under step number 4, you can see that it's taking care of that for precipitation and for temperature. And then it's handling the issues corresponding to wind values. And now it's checking for any duplicate dates, checking for any missing values. And here it's doing a standardization of the weather column. Well, nothing too crucial, but just making sure that things are consistent. For example, having all the entries in lowercase and getting rid of any spaces that we might not really see when we first inspect the data, which can actually cause a lot of trouble, especially if you're doing things like filtering operations. Spaces like this can cause a huge problem, so you need to get rid of those. Alright guys, so all in all, I'm pretty happy with the outputs of both models. And if I talk about Claude, specifically for generating a very comprehensive Python script like this, I mean, it couldn't get better than this. Detailing out all the steps in a very systematic manner, separating the major tasks using different functions like this, which is something that I really like. So somebody can actually take this code and decide to use it in their favorite IDE. And if they want to make any further tweaks, they can actually go ahead and do that. So in that sense, I really like the output of Claude Sonnet 3.7. And what I can definitely notice is that for a somewhat experienced Python user, this is just golden. You've basically got everything you need with the option of being able to make any changes accordingly. And at the same time, I really like how Grok 3 actually broke down each step into this sort of a notebook type output with the subsections wherever appropriate, like this, for example, having subsections to address issues related to different columns and having chunks of code for each section, which might make things more clear, especially for a novice user. Alright, with that, I'm actually going to move on to the second task, which is a data visualization task. And I'm basically going to use the same dataset, and I have gone ahead and cleaned it based on the feedback we received in the previous step. And in the field of data science and analytics, visualizations is a big deal. So I'm going to instruct both models to help me understand the summary and key information of this dataset by creating visualizations of the data using multiple charts and graphs to extract and highlight key insights. So when you're looking at a dataset like this, even a more complex one than this, having multiple columns and thousands of rows, it might be difficult for us to immediately deduce what's being said from this data, and visualizing this data in some way to obtain the summary and the key insights can be a really nice way to sort of get the hang of the data before we dive into the specifics. So let's instruct both models to create these visualizations and check how much of an intervention it needs from our side to finally get to the output that we're looking for. And I'm going to attach the CSV file again. And let's go ahead and run. Alright guys, look at this. Let's close this for a second and see what sort of a process it went through and what kind of insights it extract from the data. And over here you can see it basically decides to go through a summary of the data set. And these are the insights that it actually managed to extract: temperature patterns, precipitation analysis, wind patterns, weather type distribution, and seasonal characteristics. So it really extracted all of this information: the temperature range, average temperature range, seasonal patterns, hottest days, and stuff like that. And when it comes to text-based data like this weather type, we can see that it was actually smart enough to recommend this sort of an approach where it calculates out of the entire data set how many rainy days it had, and over here it displays it as a percentage, how many sunny days, and so on. I think the highlight is it actually managed to generate a bunch of different interactive charts like this, where I could just simply hover my mouse pointer over the graph like this, and I would be able to see the corresponding minimum and maximum temperature values along with the date. And when it comes to monthly precipitation, we can see the monthly precipitation variations. Now remember guys, in the original dataset, what we had was actually daily values. So it managed to aggregate those and generate monthly precipitation values, and then decided to go for a plot like this. And we have seasonal weather comparisons and the distribution of weather conditions, as I mentioned to you guys, and the relationships between temperature and wind, monthly wind patterns. And at the bottom, it actually displays a nice summary of all of this information that it generated as a text in this main interface, sort of as an add-on to this set of charts. Now I'm really impressed guys, because if you're a data analyst, you probably would know how much of time and effort you would actually have to go through to generate this kind of an output, especially if you're doing things from the beginning. Definitely it's not something that's too complex, but just comparing the time it would have actually taken for a person to do all of this by themselves, and then these AI models coming in and doing this for you just in a matter of few seconds, that's pretty amazing. And if you're interested in looking at the code, you can actually take a look at the code right here as well. And if I were to jump over to the output of Grok 3, well, let's just try to see what sort of insights it managed to grab. So right over here, you can see that it suggests generating a graph like this. But over here, Claude model decides to go with monthly temperature trends. But Grok 3 is suggesting an average daily temperature line graph like this, which can reveal things like seasonal patterns and fluctuations throughout the years. And for monthly precipitation, I would have actually preferred a bar chart rather than a chart like this, where each bar could actually indicate the monthly precipitation. That would be much more clear rather than having this sort of a continuous line for precipitation. And for wind speeds, it's suggesting a distribution histogram rather than displaying the actual values as a time series like this. So this is more of a statistical approach, which can be quite helpful at times as well. And over here, it's suggesting a bar chart displaying the count of each weather types. And right over here, I think what we had was something similar, the count of each weather type, but Claude model decided to go with a pie chart like this, whereas Grok 3 is actually suggesting a bar chart. Well, both can be useful. I don't think one is definitely better than the other, particularly for this case. And something that I didn't see over here is actually a correlation heat map, a heat map visualizing the correlation metrics of the numerical variables, temperature, maximum, minimum precipitation, and wind speed. This would be really nice just to see how correlated these climatic variables are just in one graph. Finally, it's suggesting a temperature versus precipitation scatter plot. Well, this can be quite useful as well. You can see that it says that it won't generate the plots here, but I did go ahead and ask, are you able to generate the plots? So you can see that it says no, it's not able to directly generate plots because of the nature of this model. And that's a clear difference between Grok 3 and Claude AI model as well. So Grok 3 is just a text-based AI model where it's not able to perform this sort of analysis and generate this type of dashboard type outputs directly into its interface. So definitely the points here go to this Claude AI model. However, what it managed to do is it actually managed to give me the Python code for all these different steps for displaying all these charts. And again, guys, a clear difference that I can see is that if you even try to look at the code generated by Claude AI model, and simply by looking at the libraries it actually used to generate this sort of an interactive chart, you can see that to make use of this sort of an output, you need to have some sort of a proficiency in using these libraries. But if you are a beginner or someone who is just getting started, you can see that Grok 3 AI model is keeping things simple. It's just using the pandas library. It's as straightforward and as simple as it can get. And for each output, it actually keeping things quite simple. And if you were to type this out to a code editor, you're just going to get some static outputs and nothing fancy like this. So guys, these are the pros and cons, and I think it's fair to actually give the point here to the Claude model because it decided to go down this route, even though I didn't even specifically request for this sort of a dashboard type output. However, I'm not putting down Grok 3 AI model at all because this is the type of output a novice user would generally prefer to deal with in case if they want to delve more into the code and see where they can make changes. But if you just wanted to get the output and didn't really want to bother about the code, then of course it goes without saying that it's really amazing that it's able to generate this sort of dashboard type outputs directly within the platform without us actually having to take this code and having to use it in a separate development environment. Alright, in this third task, we are going to assess the ability of both Claude 3.7 Sonnets and Grok 3's ability to select the right machine learning algorithm for a specific prediction task that I'm intending to carry out. Now, as you may know, there exist dozens of machine learning and deep learning algorithms, some designed specifically for certain tasks and are typically suitable for certain applications than others. So when developing machine learning models, selecting the right model depending on the nature of the task is also one of the challenges faced by a data scientist. So that's where recommendations from these AI assistants can come in handy. So what I'm going to do is I'm actually going to describe the nature of the task that I'm intending to do. And then I'm going to ask what would be the most suitable, or if there's more than one, what are the most suitable algorithms that I can use to build my machine learning model based on the nature of the problem and the reasons for selecting it over the others. So if I were to describe the task, I'm working on a problem related to traffic congestion prediction in a smart city, and the goal is to predict congestion levels at different locations across the city 15 minutes into the future using real-time data from various sources. And then I'm asking what is the best machine learning approach or the model that's suitable for a task like this and your reasons for selecting that. I'm excited to see what both of these models are actually going to spit out for this particular request. So let's just go ahead and copy the prompt like this and give it a go and see what sort of an output we're going to get. Very well. You can see that both LLMs actually propose the same algorithm for this task. And to be honest, I was actually expecting an algorithm which could take into account the network structure of the roads, which can be represented as a graph like this. And both of these models are actually recommending the use of spatiotemporal graph neural networks for this, which means we are not just making use of the time series datasets that are coming from the sensors, but also we take into account the spatial connectivity of the road, which is extremely important for a task of this nature. And they have captured that requirement right over here, the need to handle the spatial dependencies as well as the temporal dynamics, which has been outlined under this point in Grok 3 model as well. It also highlights the ability of spatiotemporal graph neural networks to integrate various types of heterogeneous data. Things like traffic sensor data, weather conditions, various events and things like that. And that's explained right over here as well. And I really like that both of these recommended the specific usage of diffusion control recurrent neural networks and graph wavenets as some specific implementations to consider, because spatiotemporal graph neural networks can be a bit of a broad category, and within that there are different variants as well. And we can see that it managed to capture and recommend these two variants as its top recommendations. And while the outputs were definitely head-to-head, I did like the fact that Grok 3's output was a bit more detailed in its explanations, whereas the outputs from Claude are more concise. Some actually might prefer those short, concise answers, but I definitely prefer these detailed explanations. And one thing that I really like is that it actually explains why some of these other common approaches or why some of these other methods might actually fall short for a task like this. For example, the traditional time series models like ARIMA models, and why it might not really be suitable, particularly for a task like this, where it needs to deal with multivariate data and won't have that spatial awareness because it's not a graph-based method. So similarly, using LSTMs, convolutional neural network-based LSTMs and transformers, why all of these might not really be the best method to use for this particular task. All of that has been mentioned right over here. So in this particular task, both of these LLMs managed to pick the same machine learning or the same deep learning model in this particular case as its recommendation, but I do really like the output of Grok 3 a tad bit just because of the way how it structures its response with proper justifications rather than being very concise like this. Alright, with that, we have come to the final task, which is checking how well Claude 3.7 Sonnet and Grok 3 can help in providing me with the appropriate steps for developing a machine learning model for a specific task. Well, in this case, I have selected a face recognition type task. However, there's going to be a constraint. And the reason why I'm putting this constraint is that I want to see how creative these models can be in their responses when it comes to suggesting things when we're dealing with conditions with some constraints in it. Now, the task that I'm proposing is when we have two input channels like this, the user is going to provide two different images, and the model should tell me whether it's the same person in both images or whether it's two different people. Now, if you're familiar with algorithms like convolutional neural networks, they're very, very widely used for these types of image recognition tasks. But for this task, again, for the reasons that I mentioned, I'm going to add a constraint saying that I have access to only 3 Python libraries: NumPy for dealing matrices and things like that, pandas for any data manipulation type tasks, and scikit-learn, which is a basic standard library that's very commonly used for building machine learning models. Now, I'm really curious to know how Claude 3.7 Sonnet and Grok 3 would analyze this problem, what the thought process would be in coming up with the right workflow for this problem, and especially what sort of feature extraction methods they're going to use or to propose, basically to numerically recognize the difference between the two images to judge whether it's the same person or not. So my prompt is going to be, I want to create a machine learning model that, when given two images as inputs, determines whether they depict the same person or two different people. The constraint is that, well, apart from the standard Python libraries, I'm only allowed to use NumPy, pandas, and scikit-learn. Provide me with the approach for this and the code template. So I'm just going to put that prompt right here and here as well, and let's just give it a run and see what sort of an output we are going to get. And over here you can see that Claude's output was much faster and Grok took about 75 seconds to go through its thought process. And without taking a look at the code, let's just go through what sort of an output it generated. So over here you can see that at a broad level it provided me with 4 different steps: extracting the facial features using classic computer vision techniques, creating feature vectors representing each face, then training a classifier, and then evaluating the model's performance. Now, something that I'm quite interested to know is how it actually decided to go about this step, which is feature extraction, because this is the step where it actually determines the approach to numerically recognize the differences between the two images. And over here, it decides to use histogram of oriented gradients to extract the features from images. It then decides to use the absolute difference between the features and the element-wise product to capture the variations and to capture the similarities. After that, it's basically going through a process of applying dimensionality reduction, which is quite common in this type of exercises, where it just reduces the number of dimensions it has to work with from a large number to a smaller number, and then it performs the classification task, and for this particular task it's actually proposing to use a support vector machine type of a classifier. There are other common classifiers as well, such as random forest, or you could have even used a simple artificial neural network type of a classifier. So let's jump over to the response of Grok 3 and see what sort of an output it generated. So right off the bat, it actually mentions that for tasks like this, using advanced deep learning libraries like TensorFlow and PyTorch is what's being done in the standard practice. But as I specifically mentioned that we are going to avoid any other deep learning libraries like that, it has to work with just the 3 libraries that I mentioned. And well, over here it mentions that this is going to be a binary classification problem. Our task is to identify whether it's the same person or not. And here it's going to create a traditional machine learning pipeline. And I'm going to directly jump into the feature extraction step because I'm really curious to know how it actually goes about this process. So it says collect all the images from the training pairs. And a key difference that I can notice right off the bat is that it's actually applying the dimensionality reduction techniques before it goes ahead and calculates the pairwise feature differences. And over here, it's proposing to use Euclidean distance between the PCA projections. And the rest is basically the same. So we have been given the code right over here as well. And in terms of the classifier, well, it's deciding to use logistic regression as a classifier. And I can understand the reason for that because we're actually doing a binary classification task. But that's not to say necessarily that this is going to work better than support vector machines. But I'm not really going to run these 2 scripts to find out which one works the best, but I just wanted to see the thought process and the general workflow suggested by both of these. So you can see there are actually some differences, and it's kind of hard to tell which one works best just by looking at the output like this. We probably would have to go ahead and implement this and find out which method works the best. And you can see Claude even suggests an approach like grid search CV method, which means within a defined range using multiple hyperparameters so that the model will try out all these different parameter combinations and decide which parameter combination resulted in the highest accuracy when it comes to doing the tests. So with that, we have come to the end of this video. And I think we certainly got to experience some strengths and weaknesses of both of these AI models, and in general, they perform really well as AI assistants. If you were a data analyst or a data scientist, the amount of time it took for you to perform tasks like this has now been cut down to just a small fraction of it with tools like Claude 3.7 Sonnet and Grok 3. And I think it's worth noting how Claude can be very concise in describing things and sometimes uses more advanced approaches for performing coding tasks. And I think even that's the general observation by many others as well, where Grok 3 takes a more standard approach with more detailed explanations which might be suitable especially for novice users or beginners. So guys, I'm really curious to know what your thoughts are. Leave a comment down below and let me know what you think about these 2 AI models, and I'll see you again with another video soon.